So last class we went over some statistical analysis. I'm going to be reviewing some of the concepts that we learned in this video. If you feel it's a little bit fast, go ahead, pause the video, or you can slow it down. So in this video we're going to be going over the hypothesis and the null hypothesis, the average or the mean, what it means to have normal distribution, a histogram, standard deviation, variance, and sample size, then the t-test and probability value, and how you can make that into a bar graph with error bars. So our research question is, for this example, will soda help plants grow? And in order to test this, we came up with the hypothesis. If we water one field with water and another field with soda, then there would be a difference in the amount of plant growth between the water field and the soda field. Now, in order to come up with the null hypothesis, we want to think of the opposite of the hypothesis. So, if the hypothesis isn't true, what would we say? And we can say, if we water one field with water and another field with soda, then there would be no difference in the amount of plant growth between the water field and the soda field. So, say that we did this experiment and we took a field with plants and we watered it with water, and then we took another field and instead of water we used soda, and then we decided to collect the result and take the plant weight of a sample of plants in the field in ounces, and then record the weight of each plant in this list. So this list is from the water field, and it has the first plant was 14 ounces, second was 15. From the soda field, the first was 15.9, and then again, and so on. If we want to find the average of each group, which is the central value of a set of numbers, then we'll want to type in this formula. Another sign for average is this funny looking U, or another way of saying it is mu. I know it sounds a little funny. Mu. So you find the average or you find a mu. Now, as a reminder, in order to do that, you press equals average, and there it is. You can click it. And then you take and you can highlight the range that you want to find the average for. So this is the average for the water field. And then we could do that for the next one, which is this range. Enter. And this is the average for the soda field. Now, the next part is looking at normal distribution. And it's important to talk about this before we talk about the next topic, standard deviation. So you may have seen this picture before, where it's a graph that looks what we call a bell curve, or it looks kind of like a bell, where it goes off on one side and it goes off on the other. And if a graph has this kind of shape, then we say that it has a normal distribution. Now, how do we determine whether or not a sample has a normal distribution? Well, we can make a histogram. That's what we can do for this data set. So I'm going to highlight the samples. I'm going to do insert chart. Oh, I get something a little bit funky. I get a line chart. We don't want a line chart. We want a histogram, which, if you scroll all the way down, is going to be this column right here where it says histogram chart. So I'll click that. Now this is my histogram for the water field. Do we think that this looks kind of like this. Yeah, it does. Now, a histogram represents the spread of data. So we would say that the spread of data has a normal distribution as a bell shape. So that's from the water. And now we want to do that for the soda field as well. Oh, dictionary just popped up. 1 second. Insert chart. Now I'm highlighting soda at the top because I want it to automatically go into the title. You don't have to, but you can also, because you could also manually insert the title too. Now this is the distribution of data for the soda field, and it looks like it has a normal distribution because it starts low and it looks kind of like a bell. It might look a little bit different than the bell shape that we want to see, but it still has that bell shape, so it does have a normal distribution. Perfect. So we can see that each graph has a normal distribution, and we created our histogram. So now we want to find standard deviation. Standard deviation is the measure of the amount of variation or dispersion of a set of values. It can also be represented by this funky looking O, or lowercase sigma. Now, in order to get a better idea of what this standard deviation means, you could say the spread around the mean, or mu, where if you have something that has normal distribution, has that bell curve, then you would take the mean and you would add 1 standard deviation and subtract 1 standard deviation, and the range from where the mean minus 1 standard deviation to the mean plus 1 standard deviation is going to represent 68%, or 34 plus 34%, 68% of your data. If you decide to not just do 1 standard deviation, but go up 2 standard deviations, so you take the mean plus 2 standard deviations and the mean minus 2 standard deviations, then that's going to represent 13.59 plus this, plus this, plus this, or collectively 98% of your data. Now we're going to use this for making the graph, for the bar graph. But in order to calculate standard deviation, what you do is you do equals STDEV, or this value here, and then you highlight the values that you want to find the standard deviation for, and you hit enter. And then we'll also want to do that over here, equals STDEV, parentheses, highlight the values that you want to find the standard deviation for, and hit enter. Make sure that you have the parentheses and the equal sign and everything that you need correct, because Google Sheets can be a little bit finicky. So now this is saying that if we take the average and we add 1 standard deviation, or 0.5 here, and we subtract 0.5, then those two numbers are going to be the range for that 68% of the data that we talked about. Now, in order to find variance, or the measure of how far a set of numbers is spread out from the average, all you need to do is square standard deviation. So you could take equals, and you could take the standard deviation, or you could just take this, caret 2. That means that I'm squaring it, and that would be the variance. Another way that you could do it is you could do equals var, or variance, and then you could highlight the sample that you want to take the variance for, and look, we get the same number. So then I'll also do that over here, equals var, and then I'm going to highlight it once. Now this is the variance for the water and the soda. To understand variance, it might be helpful to look at this picture, or we can see, since standard deviation and variance are connected, you can see something like this, which has a standard deviation of 5. We would say it has a low variance, and this is what the bell curve would look like. It's really high, and it's kind of together. If we have a high standard deviation and a high variance, and the bell curve is going to look like this, it's going to be a little bit more spread out. Now, so you went over standard deviation and variance. Now to go over sample size, this is just the number of samples, or I guess like the number of plants in our population. So you could manually count like 1, 2, 3, but that's kind of tedious. So you could also do a function called count, and you would do the equal sign, count, and then you would just highlight what you want. So this is telling us that we have 16, and then I could do it over here too. Count, and look, it's suggested for me. 16. Count is also represented by the letter N. So we have standard deviation, variance, sample size. So now the next thing that we're going to move into is the t-test. This test measures if there's a significant difference between two groups, and the groups must have a normal distribution. We confirmed that each group, water and soda, had a normal distribution when we created the histogram, so we're all good there. Now, an interesting idea is that the guy who came up with the t-test was William Seeley Goss, and when he published his ideas on the t-test, he published it under a pseudonym, Student. So instead of his name, he put Student. So sometimes it's called the Student t-test. Now, in order to find the t-test, there's a couple of different things. It's a little bit more intensive. But before, so what we're going to do, before we start writing it, I'm going to explain briefly what the tail is and what paired or unpaired means. So tail is a little bit of higher statistics. It's, if you would put a 1, that would mean one tail, and it means that we're measuring one side of the histogram, or that representation of data that we had. Two tail means we're measuring both sides of the histogram. For our purposes, we're going to put two tail. Now, paired or unpaired, if it's paired, it means that the population data came from the same, group. So a good example of paired data is if you have a group of students and you gave them a quiz one week, and then the next week you gave them another quiz, and then you were comparing the scores from those two quizzes. Since you used the same students, that would be, paired. Unpaired is if you don't use the same group. So we aren't using the same group because we're using two different fields. We aren't growing it on the same field, we're using two different fields. And there's two types of unpaired. Unpaired where the variances are the same, and unpaired where the variances are not the same. In order to know the difference, we just look at the variances. These are the variances between the two. They are not the same, so we're going to go ahead and put 3. Unpaired and variances are not the same for the t-test. You don't need to know tail or paired or unpaired, but if this helps you understand why we chose it, then hopefully it'll help you better understand the t-test. So now in order to do the t-test, we're going to follow these steps. Put an equal sign, t-tests, in parentheses, we're going to take our first group, comma, our second group, comma. So now we have our two groups of data. Since this is a two-tailed, as we said before, you notice where it says tails here, we're going to put a 2. And since it's unpaired without equal variance, we're going to put a 3. And parentheses, enter. Now, this is the value we get, 0.001, and it goes on. Google Sheets returns, when you run a t-test, the p-value, or the probability value, which is the probability of obtaining the results. It's standard to compare the p-value to 0.05. So if the p-value is greater than 0.05, then you would accept the null hypothesis. You would accept that your hypothesis is not true, and you would reject the hypothesis. If your p-value is less, this means that the p-value being greater than 0.05 means that it's not statistically significant. If the p-value is less than 0.05, then you reject the null hypothesis, and you would accept your hypothesis. It is statistically significant. So our p-value is 0.00178. 0.178. This, 0.0178. Oh, actually 0.00178. This is less than 0.05, our probability value. Since it's less than 0.05, we're going to reject the null hypothesis. So we're going to reject this idea, and we're going to accept our hypothesis. We're going to accept that there is a difference in the amount of plant growth between the water field and the soda field. Now we want to apply this and make something that represents it. So we're going to make a bar graph using the average mean and the standard deviation. I'm just going to copy these over into a new sheet. And I can't just paste the numbers, I need to paste special, so I right-clicked, I paste special, and paste values only. So this is the standard deviation, and this is the average. Or I guess we could say the average plant weights in ounces. This was for the field with water, and this was for the field with soda. Now I'm going to highlight just this part, insert a chart, and see, oh yes, we were lucky, we got the bar graph. If you didn't get this graph, go to column chart type, and look for the column chart. And if it doesn't look like this, if it's the same color, that means that you have to click switch rows and columns, but we want there to be different colors. The reason that I included the water and the soda part of the text in here is so that it would automatically differentiate between the two. Now we want to add error bars. And what we're going to do for error bars is we want the error bars to represent, you could say, how much the error bars are going to represent the standard deviation. It's going to represent the percent of data within a certain range. So we remember that this was calculated for 1 standard deviation. And we know that one standard deviation is equal to 68% of our data around the mean. Because when we looked at this picture back here, we saw mean minus 1 standard deviation plus 1 standard deviation, and that range is 68% of our data. Now, I would like to make error bars for more than 68% of our data. I would like to make error bars for 98% of our data, which is plus 2 standard deviations about the mean and minus 2 standard deviations. This collectively is 98%. So I'm just going to find 2 standard deviations, or 98% of our data around the mean. Here. And in order to do that, I'm just going to calculate each standard deviation by 2. This is 1 standard deviation, so if I multiply it by 2, I'm just going to put a caret 2. That'll give me 2 standard deviations, and I'll do that, oops, not a caret, a star. That represents multiplying. And I'll do that for the next one too. Star 2. So now this represents 2 standard deviations. In order to include the error bars, we're going to double click on our graph to get the setup. We're going to go to Customize, down to Series. From Series, you're going to click the one that you want the standard deviation for. We're going to start with water. You'll click error bars. Make sure that it's not percent, it's a constant. And right now it's saying the value is 10, but we want it to represent 2 standard deviations, which is going to be 1.01. So it automatically adjusts. Now we'll do that for soda. Since this is soda's standard deviation, soda and water. I'm going to go to soda, click the error bar, make it constant, and make the value 0.96. I'm going to add a better chart title, comparison of average plant weights on fields with water or soda. I'm going to make my x-axis is going to be plant weights, and my y-axis is going to be water versus soda. And it looks like this is here for some reason. I believe it's because we put this here. So if we delete this, yep, there we go. It's going away. So this is the kind of graph we want. Thanks for watching this video. If you have any questions, please feel free to email Dr. Duran or myself.